Okay, so this is part two, creating a FSM to control our ALU. We're to control our ALU without feedback. In the previous video, we controlled an ALU with feedback. This time we're going through it without feedback. So again, it's requiring us to create an FSM that causes our ALU to perform all of its operations at least once. We set our own conditions, but basically we should be going through all of our operations within the ALU. So our FSM will walk us through with that. And looking at our ALU, again, these are the operations we'll go through: and, add, subtract, NAND, or. In our initial state and starting out after pressing the reset, we should AND our two values together, and this is unconditional since we are showing all of our operations. So as soon as it's going to AND, our FSM will automatically go into our next state, our 001 state, and then after adding, it will go into 010, and so on. So that is our process. If we look at our FSM, we see that in our initial state, we do the AND operation here, and then we proceed to our next state. In our next state, we perform our next operation, proceed to the next state, and so on. Okay, so continuing to our simulation, we start in the initial state on the reset. So we would be in 0011. Oh, and if we go to our test bench as well, our inputs this time are 0011 and 0011. So we'll be ANDing those starting out. So we will have 0011 as our result. Moving on to adding, add the two numbers together, we get 0110. Subtracting, get 0. Moving on to NANDing, we have 1100 as our output, and our last conditions, or our last operation is ORing, where we see we have a 0011 output. So those are all our operations met.